Merci. Merci à tous d'être là. Merci Nicolas, Sébastien et Gisèle pour l'invitation. Ça me fait très plaisir d'être devant vous. Alors, je ferai la présentation en anglais, d'accord? Mais bon, bien sûr, si vous avez des questions, n'hésitez pas à me poser des questions en anglais, en français, en italien, si vous voulez, c'est pareil. Alors, what are we going to discuss today? So I think the three keywords are there. So we have argumentation, and I will explain you a bit what I mean by argumentation, because it's not only argumentation in computer science, but also in philosophy and in linguistics. Then there is natural language or natural language processing, which is now one of the, I mean, it has always been an important area in AI. Now it's really gaining importance with all these transformer models. So we have these GPT-3 and so on. And then explanations, which is the goal of this presentation. So first, who I am. So I am a CNRS researcher at Laboratoire I3S, which is in the south of France, in Nice, in Sophia Antipolis. And my main research topics are argumentation theory, argument mining. So this is a kind of new research area which started less than 10 years ago. We started talking about how to extract arguments and argument structures from text. So that was the goal. And I will explain you today why this is important also in the light of producing explanations, because we want to explain to ideally to whom? To other people. We want to explain something. And so, well, the best way, or one of the best ways to explain is through language, okay? Through the language we are using when we discuss with each other. That's what happens usually. When we exchange with each other, we engage in a dialogue. And when there are aspects that are unclear, we ask for more details, we ask for explanations. And usually people in front of us are willing to provide new arguments to let us understand, okay? So that's what happened. In general, I'm interested in different kinds of applications. So in law, in medicine, in social media, and I work only on a kind of related topic to explanations, which is counter-argumentation generation, in particular with respect to two issues, which are hate speech and disinformation. So today, I will present you some open questions and some results in argument mining, some open questions in particular regarding explanations. And then I will present you briefly what's the goal of a European project, which is just started in April, about generating a natural language explanations through arguments for medicine. Okay, so I will use this scenario to explain you what we are working on. So, what is let's say a high quality explanations? This, I think, it's an important keyword, high quality, because we don't want just explanations. We can have many things which could be explanations, but we want the explanation to be successful, meaning to be effective, to work. Okay, so when you have a discussion with someone, and if you don't succeed in explaining this person something, okay, your research results, okay, for instance, well, when they ask for more details, if you fail in explaining, well, even if you were doing a kind of explanations, this was not that useful, okay? So there is always a kind of, I would say, pragmatic interest in constructing explanations, which we should take into account. And for doing so, one key question is always who's the target, okay? So to whom you are going to explain what, okay? So you cannot put all the explanations on the same level, because they are not, okay? So if you want to explain something to your grandmother, it's not the same as explaining something to one of your colleagues, okay? It's not the same. And then this is the same for every kind of explanations. Okay? So you have to keep in mind that there is a target. Ideally, if the target is a kind of a human target, okay, you should target either visual or textual explanations in such a way to make them sense of it. So first of all, the thing is that we should try to find the proper level of generality, specificity of the explanation. Okay, so if you go too much into the details, you risk to be too precise, okay, and people risk to get lost. But if you are too general, the explanations risk to be a bit useless, okay, so a bit straightforward. So this is a balance. I mean, it's easy to write that. It's very difficult to understand what is the right level of specificity or generality. Then it should always try to, let's say, to make a reference to specific elements that have contributed to the deliberation. Okay, so for instance, in medicine, if there are a number of previous, let's say, cases that has drawn to a certain decision, meaning that a certain treatment has been chosen, and I mean, the treatment has been proved to be effective. And then there are also a number of best practice in medicine, so how to deal with certain diseases. Well, all the specific elements that have contributed to this decision, so previous cases and so on, this is the same in law, for instance, has to be taken into account in the explanation. So analytic statements are also part of what you can provide to the user. One point, which is, and then I will be back on this point and later on in my talk, which is, of course, a key point, is the use of additional knowledge to provide such explanations. This is difficult, okay? This is very difficult because you need to have this additional knowledge. You need to know which is that this additional knowledge is really, let's say, pertinent to what you want to explain, okay? You need to take this knowledge and make it in a form which fits your explanation. So this is far from being straightforward. I start from what it's kind of the usual suspect, so the common sense knowledge. Okay, so the fact that this knowledge is something we should ideally have. This is more for let's say explanations in I don't know. I take an example because it's something I work on. So we have some messages that are exchanged on social networks, and some of these messages are, let's say, labeled as hate speech messages. Okay, so you want to explain why these messages are labeled as hate speech messages, and why the others are not. Okay. So there, sometimes you need some common sense knowledge because there are, I mean, some information which are high level information, common information that we all share, but that well, the machine it doesn't have this information. And then there are domain ontologies, so we can have ontologies which, in a way, formally explains certain concepts in medicine, in law, for instance, in many domains. Also, they can express also common sense knowledge, but then it is either way more difficult to capture. Different knowledge bases, knowledge graphs. Well, taking all these sources may seem to be, in a way, I don't want to say straightforward, but okay, we have it. Okay, we have this information, so we can take it. But the problem is that if you are building kind of a natural language explanation, how do you take all these elements, put them together, possibly in a sound way, okay, and express them through natural language arguments, ideally. So this is the difficult part. The use of example is important, in particular when you are proposing natural language explanations. So explaining why a certain let's say deliberation has been taken. So which through which steps the process has gone to achieve these by means of an example. This always helps, in a way, humans to better understand. So ideally, this example should be from the data that is produced on. And then the evidence supporting negative hypothesis, that's also what Alan was saying this morning. So the negative hypothesis, so the kind of negative examples are always quite valuable in this process of generating natural language explanations. And then the point is to formulate the explanations in a clearly interpretable and possible convincing way. Clearly interpretable, one part we can, in a way, we can solve it using maybe natural language explanations. That's one part. But then, well, it is it doesn't mean just that just by using natural language, then it is clearly interpretable. There are other elements that should be taken into account. The point of convincing, well, this is, of course, this is something which is which has to be mentioned, because an effective explanation is something that you understand. If you understand, it means also that you are convinced by these explanations. But then this is a kind of a silly point, because we should always take into account, I think nowadays in particular, what are all the, let's say, ethical aspects of AI. So if we go more on convincing, then we talk about persuasion. If we talk about persuasion, we are talking about humans. Okay, we can do that, but we should always pay attention, okay? Knowing that it could be, in a way, risky, okay? If we are really developing applications that want to convince humans. So what are the key features for natural language explanation? So this is in a way, of course, it's a bit my viewpoint on that. It's the viewpoint also of this project which just started. It takes into account three main elements. So on the one side, argumentation, more in terms of philosophical argumentations. So which kind of argument schemes better suits the goal of explanations, and then I will go more into the details. Then the fact of having mining the arguments from different text sources and generating new arguments which are ideally used for these explanations, okay? Used to explain through arguments. Why arguments? Because arguments are really, in a way, conceived for this purpose. The goal of argumentation is to explain your viewpoints to the other, to justify your viewpoints to the others, possibly through, let's say, sound logical arguments, but not only, because to be honest, this is not the only way humans perceive arguments. So if you just conceive purely logical arguments, they might not be, let's say, enough. Okay, sometimes you need some more, let's say, emotions expressed in arguments, just to give some pathos to the explanations and so on. So there are many aspects which has to be taken into account. When I talk about argument mining, and I will be back on that afterwards, I mean you need to mine the arguments from text. You need to build, and the first, let's say, the first way to build argument-based explanations is, in a way, what I can call extractive argument generation. So you extract arguments, and then from these arguments that are extracted, then you can build the explanations. Okay, and then you can have all the abstractive argument generation, but which is more challenging. And then the task-oriented dialogue. So the point is that, in a way, the explanation is not, let's say, kind of a, let's say, a two-step process. So it's not someone wants an explanations on this deliberation, and then let's say, the machine provides these the explanations, done, mission accomplished. It's not that only, because it is an iterative process. It's the same as what we do, okay? Precisely the same. When we engaged in a kind of a argument-based explanatory dialogues, which seems a set of buzzwords put one after the others, but I mean, it makes it has a specific meaning, okay? When we engage in this kind of dialogues, well, we wait for the feedback, of the user, of the other person, to understand whether she has understood or not. And if not, we in a way, we choose the best strategy to achieve the goal of making the other person understand. Okay, which means that maybe you go more towards, let's say, providing a precise example, or you go more towards kind of well, logical statements and so on, or you go more towards the counter examples, whatever. It depends. You go more specific, you go more general. It depends on what, in a way, the person in front of you is asking to understand. Okay, so understanding these, it's a process which, in terms of let's say natural language processing, is called task-oriented dialogue. Okay, well, the task in this case is the explanation, achieving the explanation. So in particular, well, this is there are a number of works on that. It's but in other domains, so not really in this explanation. I will concentrate mainly on these two aspects during today's lecture. So mainly argumentation and argument mining and generation. Okay, so what are explanatory arguments, explanatory dialogues, if we look at them through the lens of argumentation? So argumentation is, this is, let's say, in line with what I was saying before, a reasoning in interaction process. Okay, this is argumentation. It's not just again a one-step process, but there is always an iteration, and there are always interactions between the different arguments that are proposed and the people or the machines that are arguing using these arguments. So if we want a good explanatory argument, it should be not only rational, which is what we expect, let's say, in a way, from arguments in classical arguments, logic-based arguments, I would say, but it should be manifestly rational. Why manifestly? Because in a way, the arguers, so the people that are engaged in this argumentation, and this holds in particular if you are talking about explanations, they can see for themselves alone what is the rationale behind all the inferential steps that are taken. Okay, if all these inferential steps are not clear, okay, from the beginning to the arguers, well, they just get lost. Okay, and in a way, putting let's say, having all these steps in a way transparent to the user, this makes the process in a way explainable. Okay, so all these argumentation. Here, the aim is an explanatory dialogue based on arguments, where we reach ideally some consensus or some conclusion at the end of the dialogue. In the explanations, what we have is that an agent accepts the conclusion, but it may query the premises, like, okay, that the diagnosis you proposed is D, but why? Okay, so this is the kind of questions we would be able to answer in the same way as it is proposed. So in using natural language argument, natural language explanation. The pragmatic goal is always understanding in this kind of dialogue, and typically it is reached via causal reasoning. I will go now a bit more into the details of what are some, let's say, argument schemes that has been designed really for explanations. Okay, and I will underline why it is then difficult to use them in real explanations. Okay, because there is always a kind of a, unfortunately, kind of a gap. Okay, between what we define in a way formally and then what we can do when we do have to produce these argument-based explanations on real data with real users. there is also another point that I want to underline now, and that is also very important. There are very, 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 very few works that assess whether all these explanatory models really work for users. Okay, but this is not a small issue. Okay, because when we propose something, ideally we propose something and we say, okay, this is to increase the understanding of the users, this is to explain these decisions to the users, but then it is important also to assess whether the real users actually have understood what has been done. So this is very important also. And I will not go into the details of, let's say, human-based evaluation, because this is also a precise domain which requires, I mean, a lot of effort to be done. I mean, putting in place a user evaluation is not something which is straightforward. So let's take some, let's say, argument schemes or better dialogues, like in this example. That has been proposed. So this is a proposal from Zenker. So the idea is that we have the first question, so why S, like in the sentence that I showed you before. Then the opponent, then you can see these as two person, one person, and one AI, two AIs. Okay, you can play on that. You have because T is true and T implies S. Why should I accept T? Okay, because this is you say T is true, but I need proof of that. Because U is true and U implies T. Okay, I do accept U. I mean, this is something which is in ideally in the mind of the proponent. Do you accept T? Yes. Do you accept S? No. But you must, because T implies S. So it also shows the fact that at a certain point, let's say the explanation is considered as in a way as provided. Okay, it follows logically, and so it should be accepted. Let's look at another example, an argument schemes for explanations. So F is a finding or given set of facts. Okay, try when you read these, try to think about it in terms of, for instance, a machine learning system. Okay, because at the end, all these discussions about explanations has been raised recently now because of the fact that there are these deep models that are difficult to understand, and also a raise of certain AI applications that are not straightforward to understand how they reach their decisions. Okay, so this is something that has been proposed in argumentation, in philosophy in particular. Okay, so in a way we have the path which is in front of us on how to design these explanatory arguments. Then casting these to real use case, it's not straightforward. So that I think here you could can start perceiving what is the difficulty of doing that. This gap I was talking about. So F is a finding or given set of facts. E is a satisfactory explanation of F, and then satisfactory explanation, we can consider it in different ways, so something that is understood and so on. No alternative explanation E prime given so far is as satisfactory as E, therefore E is plausible as a hypothesis. Okay. Okay, this is a scheme. Okay, these are these argument schemes has been proposed in particular by Doug Walton and Chris Reed in kind of a informal logic-based argumentation. Okay, so they, in a way, they encode the reasoning steps, but keeping that at the level of, let's say, informal logic formalization, meaning that it's partly expressed in natural language. So this is a kind of scheme, and with the schemes we usually have and this is very important, always the critical questions. Okay, so critical questions are proposed to in a way assess the goodness of the scheme. Okay, it's a number of questions that are proposed. So these are the 4 questions that are proposed for the scheme that I showed you. So let's have a look together. So the first one is about the absolute merits of the explanation. So how satisfactory is E as an explanation of F, apart from the alternative explanations available so far in the dialogue? So this is the first question we ask, okay? The second one is about the relative merits of the explanations. So how much better an explanation is E than the alternative explanations available so far in the dialogue? Then we have the relative developmental state of the dialogue. So how far has the dialogue progressed? Okay, because we see always these explanations as an interactive process. So it is a dialogue. How we can go on with the dialogue? If the dialogue is an inquiry, how through has the search been in the investigation of the case? And finally, the comparative merit of continuing the dialogue. Would it be better to continue the dialogue further instead of drawing a conclusion at this point? Because if at the end, in a way, let's put it in this way, you are not convinced by the explanation, then the dialogue should go on, okay? Because you need to touch other elements. So if we want to cast these questions to, let's say, more NLP problems, let's say, or methods, we look at clarification questions, okay? So there are a number of task-based dialogue systems that are proposed, okay, where in a way the system is asking clarification questions, okay, to the user. This is an iterative process, and it's very, very close to kind of explanatory, okay, process, where the system asks and then given the answer, it can provide more details. These are kind of clarification questions. But if you see, there is a lot of elements which are implicit in that, okay? This is very general, okay? There are a lot of elements that are implicit, a lot of elements that are difficult to be instantiated into a concrete use case. So this is far from being straightforward to move from these questions to clarification questions that we can use in an interactive dialogue, task-based dialogue with a user for an explanation. Let's look at another example, another scheme. So we have, this is by Josephson and Josephson. This is a collection of data, facts, observations, givens, okay, whatever. H explains D, would, if true, explain D. No other hypothesis can explain D as well as H does, therefore H is probably true, okay? So here it's, first we have an element which is interesting, which is true, okay? So this is a kind of I mean, it's a truth value, which is something that is always, in a way, it's not an explanation, it's not forcefully linked to the truth, okay? So an effective explanation could also be an explanation which is not, unfortunately, an effective explanation for humans is not always linked to the fact that there are really purely logical, sound arguments that are proposed, okay? But sometimes it is persuasive enough, in a way, to work. Anyway, let's look at the questions that we have in this case. Again, you can look at all that as clarification questions, okay? But it is very difficult to move to these questions to real questions that we can instantiate. So the threshold, so how decisively does H surpass the alternatives? okay? So that is something that we can cast in a way into a machine learning setting, okay? Because we have the threshold, that's something that we can see. Internal merit, how good is H by itself independently of considering alternatives? This is difficult, okay? Because this is what we can say is linked to quality, okay? So ideally, we would say that H, if we think to H as an argument, okay, we express these through an argument. Well, what is the goodness of these, the quality of these? This is not straightforward. Data reliability. How trustworthy are data, respectively the processes by which data were obtained? This is interesting, okay? Because this again, here, as you see, with respect to the research questions, the critical questions that we were looking before, these are already much more close, let's say, to the scenario we would be willing to target, okay? But these we don't always have this answer. So how trustworthy is. So sometimes we have some kind of reliability of the data sets we have, sometimes we don't. For instance, if some data is some data that we retrieved on the web, so the reliability, it has to be assessed. Exhaustiveness, how much confidence is there that all plausible explanations have been considered? This is difficult also, okay? This is very difficult, okay? Because it depends a lot on the data you are processing, okay? Already how much data you're processing, okay? Because this is important now. With these transformer architectures, you can really have a huge amount of data, okay? Whether you have considered all the plausible explanations, that's not straightforward given the bunch of data you start with. Cost and benefits, what pragmatic considerations matter, including the cost of being wrong and the benefits of being right? This is very difficult, okay? Again, so, I mean, the pragmatic considerations are always something that are difficult to be taken into account when you produce the arguments, okay? Because if you can rely only on the data that you have, sometimes you have a kind of computational limitations, but still the data is there. For the pragmatic considerations, sometimes you have also elements from, let's say, common sense knowledge, war knowledge, and so on that you don't dispose, okay? So it's not always straightforward to calculate these costs and benefits. And then the gravity of the issue. So how strong is the need to reach a conclusion, especially considering the possibility of seeking further evidence before deciding? Again, as before, okay, here it's just expressed in a different way. But again, do we, in a way, can we make a kind of a strong conclusion, or like the one in the scheme? So this is possibly true, or we can go on, okay, because we are not yet convinced. We want further evidence to reach kind of a consensus about the truth of the. So these are questions. I think that in this scheme, which comes from to philosophers, so it's not strictly linked to machine learning. This casts better the kind of use cases that we can have with respect to the previous one. Still, there is a gap. Okay, now we go a bit more into the details of arguments and in particular argument mining. So when we want to construct arguments in such a way that we can use these natural language arguments to build explanations, okay, the first thing usually you have to do is to extract them, okay? So first you extract the arguments from data you have, textual data, and then you can employ these arguments to build what I was calling these extractive argument-based explanations. Extractive because there is first an kind of extraction process, okay, and then you combine these pieces of evidence that you extracted in order to build explanations, okay? So you have some kind of, let's say, let's call them patterns, okay, that you can use to build successful explanations. So even the task of, let's say, extracting arguments from text is not straightforward, but I think that in the area we really achieved some good results now. So the area started almost 10 years ago, a bit less, okay? I would say that it started in 2012 or less with the organization with some preliminary works, and then the organization of 2 workshops in 2014 about argument mining, really, natural language arguments. Why this task? So this task comes from the need of saying, okay, we can develop different kinds of, let's say, formal models, formal frameworks for argumentation, which of course are fundamental to take decisions, okay, based on arguments, which are in a way explainable, which are something that we can clearly see how they goes. But then, okay, how can we employ these frameworks, these formal frameworks, with what we have? So these natural language arguments, because these are the arguments that are around us, okay? It's very unlikely to find arguments already formalized in whatever kind of logic. So that's the kind of, this is the data you have, okay? Well, the task has been in a way defined as the task of analyzing discourse on the pragmatics level, which is not easy, and applying a certain argumentation theory to model and automatically analyze the data. Okay, so you decide what is the model you take into account, and then you want ideally to extract these arguments from the data, given that you use the formal frameworks to have, let's say, to achieve the reasoning part, to justify a decision, to take a decision, to explain something, okay? Then this is the final task. So why 2012, 2014, the workshops? Well, because, I mean, the advances were there, okay? There has been really a huge step that has been taken over for computational linguistics and machine learning. And so something that was not possible before, it was possible. So that's why the timing. So the idea is that you start from textual data, which is here. Then you detect the argument components. Then we will go more into the details, but let's think in general terms. Okay, we detect the argument components. Then we want to connect these arguments that you find by relations. For instance, the easiest two bipolar relations, so support and attacks. And then you have as output the annotated text, meaning that you have the text which is annotated with, okay, this is an argument component, this is not an argument component, this argument component is attacking this other argument component. So this is what I mean by annotations, okay? Meaning that you have the text, and these annotations, basically a JSON file, okay, is produced. Yes.
I got lost in the argument scheme. So I'm asking, what is the argument scheme? Is it like for each task we are proposing a scheme so that we expect to fill out the letters like the E, the F to try to explain?
It's a very good question. So I have another slides on argument schemes after, okay? But the idea, just to give you a few words and then we will go there, is argument schemes. I have shown you the ones for the explanations, for building explanations, but there are many of them. I think around 95, so almost 100 of argument schemes. So there is, for instance, the scheme from expert opinion, argument from expert opinion. So how to, in a way, assess whether an argument is proposed by an expert, how to be sure that the proposer, the proponent is really an expert, how to assess the expertise and so on, and so the goodness of the argument. There is the argument from authority. There are many. Okay, so these are used to, in a way, formalize kind of let's say the usual reasoning that we as humans are taking in the different situations of life, and it is expressed in this informal logic way. So through these sentences, so usually there is a premise and the claims and so on, and a bunch of research of critical questions, sorry, that are used to, in a way, check this scheme. That are questions that should be answered when you face these situation. Let's say, yes.
Question. Are the argument scheme the representation of the argumentation?
So
how can we represent the argumentation? I don't know, like some kind of numerical vector, or is it like a node in the graph?
Okay, I see. It's well, how do we represent it? We represent it usually through under the form of a graph, okay, where we have that the argument components, meaning the premise and the claims, are the nodes of the graph, and then we have different kind of relations between the argument components, namely, I mean, edges in the graph. That's that could be supports or attack. So that is the usual way to represent it. I was, let's say, in all that, in a way, critical questions comes together with the arguments, but are not expressed directly in the graph. Okay, so these questions are attached to the let's say, to the scheme, but are not directly expressed, encoded in the graph. But then we will go into the details. Yes, if there is, yeah, such a way that they clarify before going on.
Ok, oui, c'est une question de Romain Zudarm. Donc, en fait, sa question, c'est concernant l'aspect convaincant d'une explication. Cela veut dire qu'il est acceptable d'avoir une explication ne reflétant pas exactement le processus décisionnaire du système tant que la cible accepte l'explication.
This is a difficult question to answer, because, of course, I mean, it's this is it's difficult to find the good balance, because on the one way, I mean, let's say we would like to, in a way, ideally we are tempted to prefer purely sound logical explanations, okay? Because this is what we say, okay, this is sound, there is a precise process and so on. But then these are not always the most convincing one, because many times, let's say, the rhetorics, in a way, that is the rhetorical strategy which is employed in the argument-based explanation, sometimes it's not logos, but it's more pathos or ethos. So more those based on emotions, or those based on ethos, so the reliability of the source, the trustworthiness, and so on, the expertise. Sometimes they work much better. Okay, so in a way, ideally we would always like to have just purely logical explanations. Sometimes the other are those that work better. But here, that's what I was saying at the beginning. We are talking about, in a way, convincing let's say, our opponent, in a way, persuading him, and then we fall into all the ethical questions that has to be taken into account. So how good it is to write these purely persuasive machines, which can work very well, but sometimes, I mean, an explanation sometimes could be an effective explanation, meaning that in a way the user or our opponent is in a way accepting and say, okay, I accept, I agree. In a way, I change my viewpoint. That could be also a consequence of the explanation. Okay, we are discussing. We have we are two opposing viewpoints, and then you explain, but maybe you solicit emotions and so on, and then I change my viewpoint. And sometimes this is not good, okay? It's not always good. That's why also when I was talking about the other argument scheme, and it was the word true, the truth. So this is not always taken into account when we talk about explanations. Of course, we should always target explanations that are, let's say, good explanations. When I mean good, I mean high quality explanations, sound explanations, and so on. But we should also be aware of the fact that there could be some, in a way, misuse of these technologies that we want to develop, ideally, so these natural language explanations and so on, in order to make the machine, okay, I'm transparent, I can explain you why I take my decisions, and then I convince you that my decisions are good, okay? So let's always be aware of this. So this, of course, is not the main goal of my talk, but still I prefer to raise awareness on this issue. Okay, so I go on argument mining. Just a quick note: argument mining is not opinion mining. Okay, opinion mining / sentiment analysis. Okay, because in one way, for argument mining, we are interested in knowing why. So why the user is thinking something. If we take, for instance, product reviews, okay. Whilst in opinion mining, we are more interested in what the users think about a certain product. If they like, they don't like, what's the polarity of their opinion. So this is the beginning of argument mining, just to give you an idea. So we have the first work is by Simone Teufel in 1999, argument zoning in research articles. So how to identify automatically in an article the different kinds of arguments. So in a scientific article, where you underline, I don't know, where you compare with the related literature, where you highlight the key advantages of your approach, and so on. Then there is the first paper using the word argumentation mining, which has been proposed by Raquel Mocales and Cien Moens in 2011. So you see it's almost 10 years. And then the two workshops that were organized. So the first one in July, and the other one, it was in August 2014. So here, the first one was more from the side of, let's say, computational argumentation towards NLP. The second one, more from NLP towards computational models of arguments. So these are just to give you an idea of the history. And then, well, there are, if you are interested in all that, there are the three international associations that are that work really on argumentation. So ISA, OSA, and the newest one, so the European Conference on Argumentation, the ECA. And then this is interesting. So in a way, you can think, okay, but this is just the work of some scholars in universities and so on. It's not actually. So there are really companies working on that. In particular, the IBM company. So they proposed what is called now the debater, which is a real system, able to debate in a quite effective way with humans. Okay, so it's a bit the, let's say, in a way, its ancestor is Watson. Okay, it's always by IBM, and then now there is the debater. And if you look on YouTube, for instance, you have many videos showing this system actually debating with journalists, so taking a topic of the debate, and then there is really the arguments proposed by the system and so on. Okay, they mainly have these arguments extracted from the web. Okay, so of course. This has been a huge work of a collection of arguments from the web, annotation, really huge work. So these I already said. So just quickly, the idea is that opinion mining was first, so to understand what people think. Here we want to understand why, and then we move from opinion analysis to the next step, which is actually how to understand and analyze the reasoning process that bring human to accept or reject an argument. Okay, so how we have this, and this is also linked to explanations as well. So the idea is that what we want to do is that we want to do automatically to find, analyze, and assess the arguments at large scale. Okay, meaning that we have a huge data set of text. Okay, it could be legal text, it could be clinical essays. Okay, clinical trials. We can have messages exchanged on social networks, blogs, forums, whatever. And we want to identify the arguments there, the argument components. We want to analyze how they connect to each other, extract them, analyze them, how they are structured, but also assess them. Okay, so this is a bit the new some of the new targets in argument mining. So assessing the quality of the arguments, because not all the arguments are the same, of course. So we can have better arguments and worse arguments. Again, on that, how we assess if an argument is better than another, it's not straightforward because it depends on many elements. Again, what is the pragmatic goal of this argument? Okay, so if the pragmatic goal of the argument is only persuasion, so that's the goal. You assess the argument with respect to that. If it is soundness, then this is another goal. If it is cogency, there are many aspects that can be taken into account to assess the quality of the arguments. Ideally, we want to assess the quality of the arguments automatically. This also, okay. Also, this step should be. So this is not an easy task neither. Why do we need to do that automatically? Because, well, simply we cannot scale. Okay, if you want to analyze really huge amount of data, for instance, let's take a medical scenario. Okay, huge amount of data. We just need to have something which does this work for us. So taking the arguments, analyzing, assessing their quality, and so on. So the idea is that this computational model can process ideally heterogeneous sources and big data. Big data, yes, okay. I would say that on that I kind of agree. Heterogeneous sources, that's yes, we can, but as you will see in a few minutes, well, usually each approach that has been proposed targets kind of a specific scenario. Okay, so those that work on medical scenario, okay, so clinical texts and so on, they cannot just easily take the model as it is and applying it to the legal scenario, for instance, legal data. Okay, it's not working. Okay, so there are many. This is not only for argument mining. Okay, there are now some methods that can be used to do so, but still this is something which is not yet an easily solved point. And then we have analyzing the fact that what we want to do is to analyze this argumentation, trying to support these decisions with these arguments that we have analyzed. And then there are, well, kind of a structured summarization of text, which is close to generating argument-based explanations. Okay, it's not that far as a task. Finding the contrasting viewpoints and the recursive argumentative patterns, and these also are two elements that can be profitably used to build effective explanations. Okay, so this was the goal. This is the goal nowadays as well. So there are different perspectives that we can take into account when we talk about argument mining. The information extraction perspective. So how we extract the different argument components, the discourse understanding perspective, which is a bit more challenging, okay, because we need to follow also from a temporal point of view the arguments that are proposed and so on, and also the relations between these arguments, and finally the decision-making perspective, which is more on the pragmatics of these dialogues. And this is I would say the most difficult part in the process. So how does it work? It works as a standard, I would say standard in a way machine learning pipeline, okay, standard NLP pipeline. If we think about information extraction, okay, and classification. So we start with an argumentation theory, okay, because first we need to know what we want to extract, okay. This is the first obliged step. You cannot extract something if you don't have a clear idea what you are going to extract. First, what you target. And then you have to define an annotation scheme. So in order to annotate in a reliable way a linguistic resource, okay, you need to produce the data. Here, I'm talking about, this is something that I have to specify now, I'm talking about supervised learning, okay? So I'm not talking about clustering or semi-supervised. I'm really talking in a standard supervised learning setting of information extraction classification, okay? And then we have the machine learning method. Take one. You can take super-vector machines, naive-based decision trees, up to recurrent neural networks, transformers. You can use all the whole technology that now is available. Okay, and you evaluate. Okay, now then I will show you an example. You evaluate, and if the results unfortunately are not that good, well, you revise. Okay, because it is important to have all the elements well defined in the pipeline to make it work, to make it successful. So let's have a look at an example. Okay, so we take, for instance, kind of abstract argumentation. We take two kinds of argument components, claims and evidence, such a way that we want to identify what is the claim, what are the evidence that are proposed, and we want to identify, for instance, attacks between different claims that are proposed in, for instance, in Wikipedia articles. So Wikipedia articles were one first example of data that has been considered in the area, because they are all available. They are reasonably well written, okay, or checked in the well-known pages. Okay, they were not going into the details of unknown pages, but the big ones, and this works well for the system. So you define all that. I want to just underline something. These three first steps are very important. Okay, sometimes all the attention is focused here. Okay, so what do we use? Okay, when you I can talk about my PhD students. Okay, so when you discuss about the problem, then you say, okay, so we do this and that. Well, okay, they start saying, okay, so do I use PyTorch or I use Keras? As you say, okay, maybe it's a bit too early to discuss that. First, we need to define what. So it seems a bit straightforward. Okay, yes, of course, we want to extract these argument structures. Okay, it's very easy. It's our claims, premises. Okay, that's. But actually, defining what is a premise and what is a claim, it's not straightforward, and it depends a lot on the kind of data you are dealing with. Okay, so the definition is reasonably, let's say, good when you talk about Wikipedia articles. If you go into, for instance, political debates, Well, this is much more difficult, okay? So you need to pay attention to what you want to extract, to define carefully the annotation schemes. This is what we call the annotation guidelines, okay? This is a document that you should write, okay? It's not something that you just decide inside your mind, okay, one Friday evening, and then this is it, I annotate the data and that's done. Because this is not shareable, this is not reliable, you cannot do that, okay? So you need to define the guidelines very precise, and then you take these guidelines, you give these guidelines, I don't want to say to your grandmothers, but to someone, okay, who has not worked with you, and you say, okay, do you understand it, okay? And you will see that there are many, many, many issues that that you didn't consider, because you have many things in your mind that are implicit and you don't put them down in the guidelines, whilst the guidelines should really be complete. So all let's say all the decision elements that you have taken into account to say, I annotate these as a premise or as a claim, or I don't annotate that, okay? This has to be put really on the paper, on the guidelines, such that everybody can reproduce the same annotation, or kind of, okay? And then, of course, you annotate the data, or if you are rich annotators, so really people doing that work, and you get the data. Of course, you evaluate whether there is an agreement, okay? So whether the annotation task has been carried out by people who has the same viewpoint on the annotation, okay? They have followed the same rules, ideally, okay? If in the inter-annotator agreement, which can be measured using different metrics like Krippendorf alpha or Cohen's kappa, whatever, then if it is above a certain threshold, the resource is reliable, okay? We're only here. Sometimes this is kind of a 6 months process, okay? So that's normal, okay? It takes time. But then you see that here, well, here you get good results if you did the first 3 steps in a proper way, okay? So sometimes what I see in my students is that, and I was the same, by the way, is that this is boring, okay? This is very boring, okay? Because you spend your time writing down, precising things, and putting a lot of these examples that you feel a bit useless, okay? In these guidelines, to say, okay, this is straightforward, and keeping wasting time in defining these guidelines. It's not a research paper. It's not something that I can, in a way, concretize. Okay, then it's not something that you can. Of course, part of it is published in the papers, but it's just a small part. But these affects everything what comes after. Okay, so it's time which is well spent. So let's go on. Do you have questions? Yes.
First, I understood that you first extract the arguments, and then after that, we apply an argumentation framework in order to be able to say which are the attacks, the relations. But from this figure, it's quite a little bit different.
Well, no. What we say is correct. It's that. But to define what you want to annotate, you need to have a kind of, let's say, what is the framework you will apply later for the reasoning. You should have it in mind at the beginning, because otherwise you, let's say, can extract just other things. Okay, so you need to know what you want to extract, and you need to define it precisely. Okay, so if you want the claim, the premise, if you want only attack relations, if you want also support relation, if you want partial attacks and partial support, what do you want? Everything you want, you should define it. And try to define, the problem is that when you define these notions, let's say, formally, in a certain way, it is easy, okay? Because you know where you go, you know what are the constraints you want they satisfy, okay. But then when you look at the data, it's a mess, okay? because it's just it's so shallow. Okay, it's not I mean, well structured, and it's not it's full of exceptions. Sometimes you start writing the guidelines and you say, okay, so this is a bit an exception, but I consider it as, I don't know, a claim. Okay, it's not really well formulated, it's this way of expressing, but okay, I consider it. And then when you look, when you continue on that, looking at the data, and then when you look at the end, you look at your guidelines, you say, it's just a set of exceptions, basically. So this is important. And another point that I was, I mean, something that I didn't say before is what is very important in this process is also that you will know your data, okay? And this is important, okay? Not just taking these, in a way, black boxes that are these algorithms and taking another black box, which is the data, and feed it with this data. Well, there is nothing there, okay? So of course there is something that you can extract some information, but then you don't know what you are dealing with, okay? So also writing these guidelines, defining them properly, making a reliable annotation makes you know the data. If you know the data, you know how to target then the different features you want to use to make this task automatically, because then you will have to give some knowledge to the system, okay? So it's very important to know your data. And this is important also for the explanations, okay? So when you want to build the explanation, you need to know what you are talking about. And if you build explanations from the arguments you have, you need to know your data. So this is an example, just to give you the let's say, very broad idea, just to see the different steps, and then we will go a bit more into the details. So this is a text from Wikipedia, in particular, where we have here in gray the claims, and we have in dashed underlined the evidence. So we have the two evidence and the two claims. The idea is that we start with the text, whatever text, okay, one Wikipedia page, thousands of Wikipedia pages, and so on. The system should extract automatically these elements, okay? This is not straightforward, okay? Again, because you need to know that this, for instance, this claim starts here and ends here, okay? And not one more word, okay? And not one less, okay? Same here, okay? And then you have, then of course, there could be some kind of, let's say, degree of acceptability, even if you span a bit the window to consider, but still, okay, you need to know where is the argument component, and then you build these graphs, okay? You have that, for instance, here there is a support, so this is a kind of support relation that you predict between two nodes that are there, and the score is this one. Then here the score is lower for other, for instance, for some attacks and so on. And so those, let's say, links that you predict that have a score that is too low, you just discard them, because of course that should pass a certain threshold. And at the end, you can build what is here, okay, a kind of a standard, let's say, argumentation framework that you can have. So abstract argumentation, you have argument A attacks argument B, and B attacks A, okay? Moving through all these steps is difficult, meaning that now there are a number of architectures that are called end-to-end pipelines, okay? So meaning that end-to-end system, you give them the text and they returns you that, okay? But at the beginning, we started with different steps, okay? So first we identify the components, then sometimes this was the work and that was it, or sometimes then we identify the relations, then we put everything together and we build the graphs, okay? Now we have also architectures like, for instance, graph neural networks that can be used, for instance, to to extract the whole graph, let's say, ideally from the beginning. Still, the results are not astonishing, let's say, on this kind of data. It's not easy. What we were doing at the beginning, that is something that we are still doing in the community, is first we identify the components, meaning that first we take the text and first we identify what we called argument components and then what we called non-argument components. Then, as a second step, we discard what is non-argument component. We get rid of it. We take only the argument components. And between the argument components, we predict the relations. Okay? Let's take into account two labels only. Okay? Let's put it easy. Okay? Support and attack. We have them. And then, given that, we can have the whole argumentation graph. Okay? But still, it's a kind of 3 steps, which means also that the results, let's say, are affected by that. Because first you have a binary classification step, okay? Argumentative, non-argumentative components. Of course, that could be errors, okay? This always happens, okay? You can have errors. Then you take only those that are classified as argument components, which may contain error, meaning that there could be components that are not argumentative components. Then you want to classify them with respect to premise and claims, okay? This error, which is there, then is again propagated because, of course, if you say that something is an argument component, but it is not, and then you want to classify it as a premise or a claim, of course, you will make a wrong choice, okay? Because both of them are wrong. Just wrong choices are possible. So you propagate the error. And then when you will find the relations between them, that again, it's another error. So, I mean, these also affect the performance. It's true that the end-to-end systems are not easy to be defined. So now they get absolutely reasonable results, okay? But at the very beginning, it was better to go through a pipeline. What the pipeline also permits you is that annotating all this data for all these, let's say, tasks is a time-consuming process. Okay, so if you want to have an end-to-end pipeline, you need to have everything annotated. Okay, so you need to have argumentative, non-argumentative, premise and claims, and then all the relations. This takes a huge amount of time. Okay, of course, it depends on how much data you are annotating, but of course, if the data set is too small, it's not enough to learn something. Okay, then this is something that you need to consider. Okay, so this is an argument model that I wanted to show you because it's very, first of all, it's very famous, let's say. That's the Toulmin model, okay, that has been proposed a while ago. This is ideally an argument, okay? This is the structure of one argument. Ideally, an argument is composed by a data, which is also called evidence, a warrant, a conclusion, okay? The conclusion can be qualified, then there could be a rebuttal, you could have a rebuttal against the conclusion, and there is a backing supporting the warrant. So let's take an example. So this is an example of one argument, okay? Here it's not really a dialogical process, okay? It's more arguments that we can have in text, like legal text or clinical text. The data is, was born in Bermuda. A man born in Bermuda will legally be a British citizen. So this is a kind of the inferential step, which is in a way explicitly written. Then you have that the backing is Article 10 of the code states that a man born in Bermuda is a British citizen. this makes us to go to the conclusion, I am a British citizen. The qualifier is presumably, definitely, okay, it could be, we could have different of them. And then the rebuttal is a man born in Bermuda will legally be a British citizen unless he has betrayed Britain and become a spy of another country, okay? So this is a kind of the whole, let's say, argument. Ideally, we could say, okay, so this is a structure which is, this is well structured, okay? We can say, we go to text, okay? And we want to extract these elements, okay? This could be the argument theory that I was talking about at the beginning, the first box, okay? This is what I want to go for. Well, I ask you something. Do you know how many times you find something like that? Almost never. Okay, never. Okay, even when you expect it, there is not. Okay, so you look at that, you say, well, very good. Sometimes you have, well, often you just have that. Okay, if you go to, I don't know, social media data, whatever, you have a lot of claims. Evidence, not that many. Okay, political debates, same. Okay, you have a lot of claims, not always supported by evidence. The inferential step is almost never there, which makes things difficult because it is kind of implicit. So either you dispose of some knowledge base, knowledge graph, and so on, such that you can make it. Otherwise, you don't have this information. Okay. The baking, well, sometimes you have it, but as you don't have the warrant, it's a problem because it is baking what, okay? So even in a kind of text like the well-written legal text, okay? Even there, you don't always have everything because sometimes you have a lot of references to other articles, other law articles. It's not easy to follow the, let's say, to go to the other articles and extract this part, which again make link to another article and so on. So this is also is something which is complex. Anyway, this was a kind of a, in a way, a well-structured example of an argument scheme. But then when you look at the data you dispose of, it becomes a bit more, let's say, difficult to see how to use it. So in general, there are, well, 3 models that you can consider. And it depends a lot on the kind of data, for instance, you have. So you have rhetorical models where there is really the persuasive intention. So these you find a lot in the political dialogues, for instance, the political speeches and so on. You find a lot of rhetorics. You can find the 3 ethos, logos, pathos in particular there. Then you have the dialogical models. So how these arguments are connected in a dialogical structure, ideally with more than one arguer, okay, in the system. And then the monological ones, like, for instance, you want to find the structure of each argument and maybe further on how they connect to each other. I will show you some concrete example later on, don't worry. And then there is something, there is the elephant in the room we never talk about, which is dynamics, okay? This is another issue, okay? Because, well, arguments change and also explanations change, okay? When we were talking about explanation, sometimes a good explanation, well, it's no more an explanation then, okay? Because the situation evolves. You can find plenty of examples of explanations that don't work anymore if you think to the pandemics, okay? So something that that was explained at the beginning of the pandemic, so I don't know, February 2020, now it's no more a valid explanation. So how to, in a way, make the system aware of that and updating all that, this is super difficult. But it's something we should at least be aware of. So the monological models here, and then the dialogical ones, so where really you find the interactions between the different arguments, whilst here you have more the structure of the single argument. So about the arguments, there are also a lot of let's say, a lot of different a terminology which is used, which could be different, but at the end, at least in argument mining, it really means the same. Okay, so it's important to keep in mind all the possible definitions. So when I talk about claim or a conclusion, it's the same. In general, an argument is a set of premises, a conclusion, an inference from the premise to the conclusion. Again, premises, evidence, data, reasons, okay, for a claim, for a conclusion. Okay, these are equivalent. Okay, inference, the inferential step, the warrant, the argument. Sometimes the argument is considered the inferential step or the biggest structure. And then when we talk more in abstract terms, we have the argument is an atomic element. We don't care about its structure inside, but we are just interested in its connections with the other arguments. Attacks, if you are in a pure, let's say, Dung settings, only attacks between the arguments. Otherwise, we can also have supports or even partial relations or other relations. Okay, it really depends. If you talk about argument mining, it really depends on the application you are dealing with. And then here you have a dialogical models with all the interactions. So the argumentation schemes. So here we are. There are many papers on that, a book in particular. This is informal argumentation, and the idea is to identify errors in reasoning, so what are called fallacies. Okay, there are many of them. Actually, they are more than 60. 60 are the main ones. You have the argument from expert opinion, for instance, the argument from analogy, the argument from example, the argument from position to know, from ignorance, from authority. There are many of them. Okay, you can really have a look. Okay, sometimes let's say you given a scheme which is used, and actually if you read them, they're really schemes that are that you can easily match to real argumentation instances you see in newspapers, in political debates, and so on. And you have all these critical questions to ask in such a way to check the scheme, the reasoning process, in order to identify potential fallacies, okay, in the reasoning. Again, I don't have a slide on that, but I can say a few words. We worked on that. We worked on extracting these from text, because in a way, at the beginning we said, okay, they are very, in a way, very appealing from the NLP side, because they are formulated already in kind of natural language fashion. So it seems easier than purely logical arguments, and seems very, very natural to find them. Again, no, okay, because when you look at the schemes, like a bit the schemes about explanations that I showed you at the beginning, well, you usually don't have all these elements put really explicitly in the text. It's a lot of what are called entiments, okay? So missing premise that are hidden, that are there, that you know, that you infer, that you automatically, let's say, in your mind add to the content that you're reading. But often there is just one premise instead of, I don't know, four, for instance, and the claim, and it's not really like that. So it was very difficult to extract them. And there are, if you see in the literature on argument mining, there are very, very, very few words on argument schemes extraction, which seem strange in a way. Okay, it seems weird because you say it's so natural, so it should be closer, but no, at the end. So this is an example of expert opinion, just to give you the idea. So the measure premise, the minor premise, you can have more. That's just the version with the two, and the conclusion. So source E is an expert in subject domain S containing proposition A. E asserts that proposition A in domain S is true, false. Okay. A may plausibly be taken to be true, false. Okay. And then you have, all these questions. This is a kind of a verification of the in a way the an ethos argument. Okay, so an argument based on the credibility, on the expertise of the person who's proposing it. So how credible is he as an expert? Is he an expert in the field, and so on? If it is reliable, if he's consistent with what the other experts assert, and so on. Interesting to say that this second question, for instance, is he an expert in the field that A is in? Okay, so that's something that it's very difficult to verify in the data. Okay, because sometimes you have some textual data, but you don't have really all these informations about the source of the arguments. Okay, so it's difficult. But of course, these are used to assess the quality of the arguments. These are difficult examples. So what are the design units? What are the single units that you want? What are the boundaries of the argument components? What not to annotate? This is very important. Deep structure or shallow annotations. So how deep you want to go into these annotations. Which document better suits the chosen structure? So these are all questions you should ask when you decide to tackle, let's say, an argument mining task. Okay, because these are the questions that anyway you're asked to answer. Okay, so the single units, the boundaries of these units, and also this is very important, what not to annotate. So what you want to say, this is not an argument, because from my experience, once you start with this kind of let's say of work, depending on the data you're dealing with, sometimes you tend to consider everything as an argument. Okay, because in a way everything seems to be a premise. This seems to be a premise. This seems to be okay. The claims are a bit difficult, but the premise everything seems to be a premise. Okay, so it's really important also to define what not to annotate, because at the end, if you end up annotating everything in the text, then you just don't have the other class. So it's easy to make the classification because everything is there. So this is important also to be taken into account, and it's not always easy to answer this question. So these are elements that are important to take into account, both for mining, but also when you want to generate your argument-based explanations. So the granularity of the input, okay, the genre of the input, okay, because this plays a role. So if you're dealing with persuasive essays, it's not the same as clinical trials, it's not the same as legal text, it's not the same as social networks text. So you need to take into account the argument model you want to exploit, the granularity of the target, and the goal of the analysis. So let's see some instantiation of that. So the granularity of the input, the level of detail at which the arguments are searched for you, okay? So the text portions at the level of the paragraphs, the single sentences, you want these argument components to be intra-sentence. These are things that you have to define before, okay? Of course, you don't define that without having a look at the data, okay? Again, you want to know the data, okay? So you have your data, you have a look at the data, and you understand whether it is, depending on what you want to extract, whether it is more reasonable to concentrate on the, to analyze sentence level or intra-sentence, okay, for instance. And then you have the type of data that you have, and for all them, it's different, the kind of also of features that you'll be used, the kind of additional information that you will want to embed in order to gain to add some knowledge to the process, to the decision process. So online debates, persuasive essays, as I said, there are many of them. And we will look at an example. And then you have the specific argument model. So the vast majority, really vast majority of the approaches are taking the claim premise model, okay? And then they have support and attack relations. So quite basic structure at the beginning. Also because it was quite challenging as a task, even with only these two elements, the detection. And then the granularity of the target, so that what is the target? You want the specific argument components, you want to construct the whole argument. What is your target? Okay. Are you happy just by listing the claims and the premise? Are you happy by constructing the argument graph? It depends. It depends also on which use you want to do of that. Of course, it's not just for just playing with the arguments. And then the goal, of course. In general, the detection means that you want to that you distinguish argument components from non-argument components. And then when you have the classification is in particular for those that are argument components, classify whether it's a premise, claim, whatever. The relation prediction between them, the attribution of them, the completion of them, and then you can have many of other tasks. So this is the pipeline. This is what I was saying. Then now there are approaches which just start from that and get that, okay? Without having these as all as single steps, okay? But you can still put 2, 3 classifiers, one in row of the other, okay? So you can start with the first one, argumentatives, the boundaries, and then you have the component detection, and then you have the prediction of the relations. Of course, if you want to do, for instance, the classification, if you want to have non-arguments, premise, and claims, it's no more binary classification, okay? So you have 3 classes, okay? It's multi-class classification, so it's a bit more difficult, okay? But it could also be an option from the technical point of view. Now it's just this is just to give you an idea what are the different tasks that have been proposed. So just evidence mining or textual entailment for arguments, claim mining, only claims, only evidence, argument quality assessment, argument generation. There are some work now on that. Claim premise mining, okay. Having the whole structure and so on. Okay. Yes.
When you refer to mining, is it like the segmentation task when you try to find a part of the text, or is it like you trying to find the node into your graph of argumentation?
Well, the mining is identifying the claim and the premise, and also predict what are the relations. So basically, at the end of the mining process, you have a graph as a result, okay? In a way, you just have to put all the elements together. But if at the end you have node, okay, which are argument components, and a relation between them, where you put all these, let's say, pairs linked by an edge together, and you have a graph. So this is a kind of a automatic step that you can have. Of course, now there are also methods that do that. Let's say you start with the text and you get the graph. Okay, still the results are not super satisfying for the moment. So, but mining is extracting these elements and classifying them.
Trying to obtain the graph in the very structure or argumentation.
Yes, at the end is what you have. It's not under the form, let's say, it's not returned precisely under the form of a graph, okay? Because it's just the pairs connected by a link, but then putting together, it's basically a graph. So it's that. So let's go on because also time is flying. So there are a number of so here it's again tasks. Now I want to go to another slide. Sorry, here. Okay, so here there is a kind of a matching between what are argument mining tasks, okay, and what is, let's say, the method, okay, or that you can use to achieve these tasks. So this is in machine learning NLP, and this is the task in argument mining. So when you do the sentence detection, the argumentative sentence detection is a sentence classification task. Sentiment play a role, okay? Before I was saying that these are two different tasks, which is true, okay? I'm not revising my belief. It's just that sentiment, so the polarity of the argument, play a role, okay? Play a role in the fact that it helps in saying this is argumentative or not argumentative, because usually, for the vast majority of what I have analyzed since then, when you talk about let's say the given a sentence, you want to say, okay, this is an argument or not. Usually, if there is some sentiment, okay, it's an argument. Okay, so if the rhetorical strategies of pathos is used, then is an argument. Of course, this holds for certain genre of text, meaning, for instance, political debates. Okay, if you are looking at clinical trials, there is no sentiment. Okay, of course, because or legal text. Okay, but still, in certain kind of text, it could play a role. Question classification is also something, subjectivity prediction, that's also something, because usually arguments are subjective, as could have an important component of subjectivity. Okay. Argument component boundary detection, well, sequence labeling, okay, so given a sequence, then you label the sequence, that's the goal. There are many ways to do that. Name entity recognition, so being able to recognize, I don't know, places, organizations, people, and other elements in the text. Text segmentation, okay, so where we segment the text in such a way to define the boundaries. Boundaries are important, even though, I mean, it depends on the data you are dealing with and the task you want. I mean, how you want to use these. Otherwise, you have a kind of, let's say, don't want to say you have a sliding window, but okay, the window could change a bit. It doesn't affect too much what you are classifying. And then you have the most difficult task, which is the prediction, which is done usually like link prediction task, okay? Prediction between different argument components in this case. The discourse relational classification, which could work, but not in all kinds of data. So again, if it is political discourse and so on, it works well. If it is relations between, I don't know, different laws in legal text, it's less effective. Semantic textual similarity or textual entailment, where you have if a sentence entails another. So these are really the techniques. And then if we go into the methods, well, that's usual ones. Okay, that's not. I will not do a machine learning lecture now. I mean, it's plenty. You can find better ones everywhere now. So we started as a community with the old-fashioned machine learning, so subtle vector machine, logistic regression, and so on. And then now, to be fashion, we use neural networks, so whatever kinds, okay, transformers. So all that's I mean, usual models. There are some approaches which are semi-supervised. It starts a bit, but then it's the task is still again now a supervised task, the mining task. Okay, so this is the pipeline. So I will go quickly through that. Sorry, just go quickly through that because we already said. So the argumentative sentence detection, So what is the input that contains and so on. So what we are the argumentative sentences. This is what we said already. This is something that you can use from that's something also I already said, but just to repeat, you can have a binary classifier, which is trained to distinguish argumentative from non-argumentative. And then you leave the task of identifying which kind of argument component you deal with to the second stage. Or we can have a multi-class classifier, okay? That's what happens nowadays. Usually you start with a multi-class classifier, non-argument premise claims, if you just keep with these categories. And you can put them in one after the other, so that in a pipeline, set of binary classifiers, and one is each one is dealing with a different part of the pipeline. So, which classifiers, which features? That are the usual questions. Okay, it's not only for argument mining; it's for whatever task in. If we talk about different NLP tasks, so this is the usual questions, where these are the supervised settings. So this is what these are different approaches. Anyway, you will have the slides. So there are different approaches. This is how they have been used. Okay, so now everything is almost here. Okay, but at the beginning everything was in support vector machine. So we really started with the old methods or logistic regression and so on. As you can see, this task, okay, attracted much more attention than the other one. Okay, because then we are really moving towards the last one. But you have to think that this is really a community and a task that started in 2011 and 12, and then get a bit more popular, starting from 2015, 14. So it's recent, okay? So still we are really progressing, but as you see, the works are reasonably recent. So another commonly used feature, so well, a bag of words, embeddings, of course. So I will say this name, bird. You have all the kinds of bird. So she bird, bio bird, depends for legal text, for medical text or whatever. That works very well. So this is kind of outdated, okay. And then the usual ones, okay? So the syntactic features still play a role, okay? It's not that we just discarded. So we are still interested in knowing that there is a syntax in the text, because it's not just, I mean, it's text. So I still like to think that there is some semantics, something which is there, which is important, so that we cannot just go for these huge vectors and that everything is solved. But maybe it's just my viewpoint now, and maybe I will change my mind. Punctuation, verb tenses, discourse markers is important. Subjectivity scores, sentiment, and entity recognition. So this is something that we already seen before. So again, this is this is let's say a kind of outline of the data sets that you can have. This is the source. So this is mainly the kind of let's say areas where the research is concentrated. So legal, politics, web-based content. Why? Because this is very easy to get. Okay, this is an easy answer. Okay, scientific literature, let's say, meaning scientific articles or clinical articles and so on, and education. So these are the areas that are those that most attracted the research. You can see the size, okay? Sometimes people, in particular people from machine learning, look at the size of these data sets. They say they're really small, okay? But, well, annotating all this data, it has asked quite a work from all these people, okay? So I understand that saying 60 abstracts seems okay, really small, but even 400 essays seems really small. It's not that small, okay, as in sense of effort which is asked. One of the most promising areas is the politics, okay, because it's clearly here you have really the dialogical part. You have potentially the fallacies. You have the assessing the quality of the arguments. You have many, let's say, elements, many tasks or subtasks that are interesting there. And of course, it's a nice scenario for argumentation. So I will skip all that because otherwise I will not have time to go to the end. Anyway, you will have all the references and everything there. So that's a few examples from what we were worked on. For instance, so on Twitter, this is a work we did a while ago. It was on argument detection, so argument, non-argument, and then we classified the arguments as being factual or opinionated, and then we identified automatically the source. Okay, the source, I don't mean the account tweeting, because of course this is quite straightforward, but it's really if it was a sentence like that. So here it's the Guardian, Greek crisis, European leaders scramble for response to referendum no vote. Here the idea was to say the Guardian, he is the source. Okay, so it was in the text of the tweet, and distinguishing facts from opinion. So here you see the data, okay, how the data has been annotated and so on. How many? Okay, here we took, for instance, Grexit and Brexit. Okay, so kind of close topics, not completely different and unconnected topics. And this is what we annotated. These are the results and the features. So the results were quite good. Of course, here, when you deal with Twitter, for instance, you need to deal with emoticons, you need to deal with hashtags, okay? So these are all elements that are specific to this genre, let's say, that has to be taken into account if you want to extract in a successful way the arguments there. So this was the point. And of course, I don't want to say always, because of course, if we talk about legal data or clinical data, it's not the case, but you always need to be prepared to irony, okay? Because ironical arguments, okay, are often there, okay? And this is not always easy to identify them, because sometimes simply you don't have the background knowledge that you need to know that this is an ironic, something which contains some irony. Okay, so that's something that has to be taken into account, and that's always something which can bring to additional errors there. Then we worked on, so here you see the good pipeline, machine learning pipeline, really up to date and so on, with all these sequence classification, effect classification, the sequence tagging model with the transformer, everything. This is on clinical trials. So here there is the full pipeline, okay? So we have the argument detection, the components, the sequence classification, so relation probabilities with the components. We build the argument graphs, and then for that, we also have an effect classifier, because of sometimes you have, for instance, the IOP increased or something like that, sentences like that on elements about medicine. So with all that, you have that you want to know if the effect increased or decreased or was the same, like here. Intraocular pressure, IOP decreased, mean peak IOP is decreased, IOP decreased, okay? So being able to identify all these elements automatically in the arguments, such that to know also to characterize a bit the arguments on that. This is really for supporting what is evidence-based decision-making in medicine. So this is another example of full pipeline. Here, and this is a platform that we proposed, which is called ACTA, to really do online analysis of argument components in the clinical scenario, okay, in medical scenario. So you are connected to through ACTA to PubMed, to select the articles you're interested in on PubMed, which is a repository of let's say, articles in medicine. And it highlights automatically evidence and claims in the text, the PICO elements, which are patient intervention, I always don't remember, C, and then outcome on the treatments, and then it builds automatically the graph, the argumentation graph. And then there is the political debates that we discussed. So here again, examples on here. I just presented the first part of the pipeline. We have it. We have the whole pipeline, so also with the relations. We have a data set which is this time huge, okay, on all the political, the presidential debates in the US, okay, premise, claims, relations, everything. And the idea is to do all these, the whole argument mining pipeline. This is to then identify automatically fallacies, for instance. So trying then to kind of applying these argument schemes that we have seen to what we found, what we extracted, and see whether there are some fallacies in there. And this is the system that we built for that, which is called Disputul. Again, this is online. You can either analyze one of the debates that are there. So the whole data set is you can have a look, and it's visualized in a nicer way than a JSON file. And then you can also paste your text and analyze it automatically, as for ACTA, but this was for the political debates. So again, if we are back to, in order to, let's say, go towards the conclusion, if we are back to our explanatory dialogues based on arguments, the idea is that the argument generation state of the art is still, I mean, it's really one of the latest tasks in argument mining that has been proposed, the generation, quality assessment. So there are some approaches not really, let's say, they are still insufficient to generate effective and, more importantly, interactive explanatory dialogues. So they are able to generate some arguments, but all the interaction process that take into account the feedback of the user and so on is not considered. So again, we want to go towards the generation of arguments for explanations, for instance. We are here at the moment. So extractive argument generation. To go towards abstractive argument generation, this is still difficult. Okay, we're still. I think it's something that will be done, but for the moment, extracting and composing new arguments with what you mind is what is done at the moment. Well, here what is also difficult is how to make explanatory arguments meet high quality arguments, because we need to assess what is the quality, okay, of these explanatory arguments when we generate, okay, them. So the variability of these explanatory arguments. So we cannot just generate always the same argument, because otherwise at a certain point the task-based dialogue with the user would fail, okay, because so it shouldn't recognize that they should have a good degree of variability, no repetitiveness, because this is important in these ones. Quantity, how many of them you are able to generate, but they should make sense, okay? It's not just a matter of quantity, okay? Quantity and quality, they go together. And then standard evaluation metrics, for instance, like Bleu or BERT score, for the generation tasks that can be used. But more importantly, it's difficult to define the other two. So what are the open challenges? The open challenges are really the data, okay? Because again, if we talk about explanations, you have seen what I have shown you in the table with all the data sets. There is nothing about explanations, okay? So ideally, we would say, in a way, we should have some kind of assessment of good natural language evidence-based explanations, such that we can have our gold standard also for that. Word knowledge and specific domain knowledge, we need to employ them. So it's not only a matter of using these embeddings and so on. So we need some knowledge which should be structured, okay, that is provided to the system to allow, in particular, for generalizations, instantiations, inferences. So, for instance, true ontologies, knowledge graphs. How to evaluate explanatory dialogues? Well, as I say, the quality and quantity of the generated arguments, generated explanatory arguments. Of course, the two go together. The structural simplicity, okay, the coherence of these explanatory arguments that you generate. The minimality, because if you say too much, then it's just useless, because the explanation, then I mean the user you get tired, okay? So it needs to be effective, it needs to be minimal, and then once I think we'll really go in deep into that, we will find also further challenges that we need to tackle. And this is the final ones that's what I was saying at the beginning. So do we have any proof that these explanations actually work for humans? Okay, so we should have that at the end. So at the end, if our target is to explain to humans, we need to show that this works, because at the end, if it is just us considering that, it's not useful. So very quickly, I will go to the project, which is called Antidote. You will find it online, just to show you what we want to do, such that give you an idea. So here it's a project that started in April. Okay, it's a European project with the University of Leuven, the University Nova Lisboa, FBK in Trento. We are the leaders of the project in the University Côte d'Azur, and we have also the University of the Basque Countries. So here, the goal of this project is to build actually natural language explanations, okay, based on arguments. So the idea is our scenario is to, because the point is that there is no data, okay, for that. There are no good explanatory arguments that we can use, employ, and so on. So, and it's also not straightforward. If you think to a concrete case, what do you want the AI to do when she engages in an explanatory dialogue, okay? Because it's something, these explanations, it's something that is everywhere. It's something everybody works on, explanations. And you are, I mean, it seems straightforward, but it's not that straightforward to think concretely then what you want this AI to do. So what we said in this project is that we want it to, let's say, to do the same as a dialogue between a student and a teacher, okay? Where we have, because this kind of dialogues in medicine happens quite often, okay? So at the Faculty of Medicine, students are asked to provide an evidence-based explanation of why they go for a certain treatment for a certain patient, okay? So we ask them to produce a kind of explanation, a reasonable explanation, sound explanation. They are provided with these, okay, which are let's say the evidence, the data, if you want to talk in Toulmin's terms. And then we ask them to provide all the things. So to make them, in a way, train, for instance, or to assess how good they are in providing this evidence, this is the goal of the Antidote system. So to play the role of the student in the teacher-student dialogue, okay, in such a way that we can check whether it is providing the good reasons and so on. And once the system is trained for doing that, it can help students in providing good explanations when they are dealing with this kind of problems, when they are this kind of let's say exam to do, to improve that, to really make, in a way, assess the students, what they're doing, how good they are in providing evidence-based explanations, and improve them in an automatic way. Because otherwise, of course, there is always a teacher which has to go through all these. So this is the goal. So make the machine play the student role automatically. So this is what is summarized here. So we start with the clinical cases provided by the School of Medicine. Again, this is something that I didn't say. Well, it's important to have the experts in the loop. Okay? This is always also something which is important, because even if you are data scientist, you have not the knowledge on all the data. Okay. So it's important to keep a link with those that are really the experts on this data. So here there is the description. Then you have an ACD prediction model, which is going to predict what is the treatment, okay, for this. And then this is what it is given to the clinicians, who can ask for questions, and then it goes to the argumentative explanations model that has to provide all the let's say the answers in a way. So this is why it is a kind of clarification question based, task based dialogue. Okay, this is how we designed it, because in a way we should also be realistic. Okay, we should do something which is doable with what we have now. So it's good already to start with that. Of course, we would like to have her, okay, just answering all our questions, but now still far. So let's go to something like that. And so these arguments are provided in natural language, and the clinician, the student in this way, is engaged in this dialogue to learn how to explain the things. So this is what is done. And this is also to underline that sometimes you need also to find ways to address issues depending on the data you are disposing of. Okay, so this is something you always need to take into account. And I will conclude already late. Sorry. Thanks a lot.
Any question?
Yes.
You said that after we classify between arguments and non-arguments, we then classify them between facts and opinions.
Yes, that was an example.
We take into consideration the preference, like if it is a fact, then it is more powerful than the evidence, than the opinion, right?
Could be then, yes.
Do we take also into consideration if we have an expert or not?
Well, not in this case, because it was on Twitter, so we cannot really assess the expertise of people. So you could have some reliable account, so that's like those with the blue tick. Okay, that's okay. It's kind of reliable, or the official accounts on Twitter. Ideally, yes, you can take into account these. You can assign a different weight to the arguments depending either on your on their let's say kind. Okay, meaning that arguments of certain kind of certain categories are more important as let's say a different weight when you have to compute, for instance, the acceptability of the arguments in the argumentation framework, or you can assign a kind of trustworthiness degree to the source, and then this is also spanned to the argument. Assigning really the weight to the arguments when the arguments are there, it's more quality assessment, but it's not based purely on the category that is assigned. Yes.
My question will be a little bit general. So you showed that those approaches, the argument mining approaches, could be applied to most of NLP tasks. But I'm wondering if you show that this kind of textual information is generated, like in natural language generation or in machine translation, are those approaches still valid for those for this kind of tasks? And are they task specific or domain specific? For each of those approaches, are they task specific?
a very good question. So it's the models, let's say, the learning models are the same as in natural language generation, if it is, even if it is not arguments, but in natural language generation, it's the same, such that also the evaluation, you use a blur, you use a BERT score, so it's the same basically. It depends a lot on the kind of data you are dealing with. So it depends a lot on the scenario you are working on. So it's not the same if you work with medical data. It's really, there is a lot of difference with respect to the political debates, for instance, and same for social networks. So it's there are ways to do some kind of, don't want to say transfer learning, but still you can in a way apply something which is applied to some data, then transfer it to other kinds of data. Still, it doesn't work always, because really the notion of argument is different in this genre.
Ok, on propose qu'on s'arrête là pour l'instant. Pour avoir 15 minutes, pour avoir au moins 15 minutes.
Merci encore, Serena.
Merci encore pour l'invitation.